Hello, viewers. Welcome to Taxonomy Online Mathematics. In this episode, we are going to start another series on permutation and combination. We know permutation is talking about the arrangement of objects in some definite order. Then the combination is also talking about the selection of objects. Now, so this is just the broader sense of permutation and combination. Now, before we can really appreciate the permutation and combination, we need to understand this concept before we move on. The first concept will be the fundamental principles of counting, which is in twofold, one and two. The first one is the product rule, and the second one is the sum rule. Then we also need to understand what is factorial. So understanding these two concepts will lead us into the permutation and what combination. So what is the first one? We mentioned that the first one is going to be the product rule, which is simply saying that suppose one operation has m possible outcomes and that a second operation also has n outcomes. Then the number of possible outcomes when performing the first operation followed by the second operation is going to be the multiplication of the two. This is just like you have two jobs to be performing or to perform. Then the first job will follow the second one, whereby the two jobs cannot be done simultaneously. What will be the total possible outcome, possible ways for doing this? If let's say you are having 5 shirts and 2 knickers to pick from, you want to make a selection, 5 shirts, 2 knickers. How many possible ways can you select those shirts? Don't forget, they are of different colors. So shirt followed by knicker, or a knicker followed by a shirt. That simply means the product, there's going to be a product of the 5 times what? 2, making it 10 different ways of selecting the shirt to wear. Do we get it? That is the first principle of counting. Then in also when you have a shelf that have what? You have a bookshelf that have books. Let's say the shelf have a number of spaces to be 5 and you're having 10 books to arrange. In how many possible ways can that be performed? These are all principles of counting, which is the product rule. We can also state that, so if we have a die which is thrown and a coin which is also what? Tossed, what will be the possible outcomes? A die followed by a coin. What will be the possible outcome, total outcomes that you are going to have? So if the first operation, which is throwing of a die, doesn't have anything to do with what? Throwing of a what? Rolling of a coin, which means that there are two separate operations being performed. So we only need a die followed by a coin. But if you pick a die, how many possible outcomes that a die will have? One die, if you throw it, we can either have 1, 2, 3, 4, 5, 6. There are 6 different possible outcomes. So 6. Then if you are throwing a coin, how many possible outcomes can you get? You can only get 2 outcomes, a head or a tail. So these become what? 2. So you are going to have 12 possible outcomes in the sense of the product rule, which is the fundamental principle of all counting. This concept will be employed more when we move into the permutation and what? Combination. So let's look at the second fundamental counting, which is going to be on what? The sum. So for the sum rule also, which is the second fundamental principle of counting, supposing we have one operation which has m possible outcomes and that a second operation has n outcomes, then the number of possible outcomes of the first operation or the second operation is given by m plus n. This is the OR operation. If you can remember principles in probability, OR simply mean addition. And as we did in the beginning, shows what? Multiplication. So if we have a class of, let's say, 12 boys, and let's say we have 18 girls. Then, if a teacher wants to select a boy or a girl from this class for monitoring, you want to monitor a girl or a boy from this class, what will be the possible number of selection that he can have? So either in selection of the boys, he can select what? 12 of them. Any of them can be selected without being biased. Then in selection of the girls, all the 18 of them are up to selection or up for selection. So if you are selecting this, it means either you are going to select 12 of them. There are 12 different ways we can select this. Then there can also be 18 different ways we can select the girls. So in total, you should be having 20 possible selections. So there should be 20 possible selections that can happen in this kind of selection. So this shows the addition, which is the sum law. So we need to apply. We'll be applying more of the product rule when we deal with the permutation aspect. But we have also the sum rule, or the principle of counting for addition. Then the next thing is to deal into what a factorial is. So by definition of factorial, you can see that in mathematics, the factorial of any non-negative, we are dealing with non-negative integers, n. So n is representing all those integers that are not negative, denoted by the n exclamation. So this is n factorial, or factorial of n, is just the product of all positive integers that are less than or equals to the number. So if I am going to have n factorial, it means that n times n minus 1 times n minus 2 continues in a direction, which in some case we can end up getting into this. Or better still, we can have it n minus r plus what? 1. We explain this one as we move forward. Now, how can we explain this? If I pick 4 as the non-negative integer, which is n, if I'm picking that, that simply means that I am going to multiply 4. They said less than or equals to n. So n is 4. What number is less than? Just immediately, consecutively, less than 4. That will be 3. Less than this will be what? 2. Less than this will be 1. Then we are dealing with what? The next will be 0. But we are looking for the positive integers. So we are multiplying right away from the number down to 1. In another definition, just from the number less to 1. If I have 6 factorial, that could also be 6 times 5, 4, 3, 2, 1. So this is factorial. Remember what we did under fundamental principles of what? Counting, which is multiplication product. We know that we multiply successively. So this is what we are having under factorial. There are various applications, questions that we can delve with when it comes to factorial. That is not our concern in this episode. In the subsequent episodes, we will take questions, how questions can also be answered under factorial. So now that we understand the fundamental principles of counting, we also understand what a factorial is. We can now delve into the topic permutation and combination. I'll begin with permutation. Then in the next episode, we will take the combination aspect of that. So let's see what a permutation is all about. For a permutation, as I said in the introduction aspect of the video, we said it is an arrangement of a number of objects in a definite order. Arrangement of a distinct word object, definite order. So let's suppose we have let's say P, Q, R as 3 letters that we wanted to arrange. Arrangement of this object in some definite word order. what are the various possible ways by which we can arrange that letter. So for example, if the first arrangement will be the PQR, that's one arrangement, right? This arrangement could also be, let's say we have PRQ. Remember, under arrangement, we are not concerned about how the numbers are coming about. We just don't want to see this being repeated. But the order in which it's being arranged is very important. This is not the same as this. Then I can also deal with beginning with Q, then R, the third will be what? P. If I begin again with Q, I should be able to come to P before I come to R. Now let's begin with the R itself. R will take P and Q. Then if I take R, it will take what? Q and P. So you can see 1, 2, 3, 4, 5, 6. There are 6 various ways by which this can be arranged. Alright, that is if we are trying to have the time to arrange them. But under mathematics, if these numbers we have is more, it becomes difficult to arrange all of them in the order in which I am doing it. So by permutation definition, we can say that if I am going to arrange these 3 letters, if I pick the first letter, how many possible ways can I pick the first letter? There are 3 ways I can pick the first letter because there are 3 letters. So in this, I can say that the first slot, if I'm having 3, so if I have this, the first slot, I have 3 ways of selecting it. The moment I select the first letter, I am left with only 2 letters for the second position. So if I have taken P, if I have taken P, Q, Q, R or R, the moment the R is selected, I am left with only P and Q to be selected. So to me, I am left with 2 ways by which the second position can be occupied. So I have 2 ways. So let's just say I am taking this as a selection. First letter is selected, second letter is selected. How many other ways can I select the last letter? That will be 1. So I have this. So remember that we are saying that the selection of P does not affect the selection of what? Q. It does not affect that of the R. So it means by fundamental principle of counting, we can say that this is selected followed by this independently. So we can introduce the multiplication we are having. So that means 3 times 2 times 1, which also give us what? 6 different ways of selecting 3 letters if we are picking all are going to be selected. Do you get it? So you can see from factorial. So the idea of factorial is being employed here. So that is why under permutation, if I am going to, I'm having n different items or objects, as in this case letters, and I want to find the total number of arrangement that could be. That is what we say that if I have the n factorial, it should be n minus 1, n minus 2 in that order, getting to the end of it. So that is where the factorial is coming in. The number, there are 3 letters, so 3 factorial ways, right? 3 factorial means 3 times 2 times 1. That is what it means. But in this example, what are we doing? We are selecting all the 3 letters. 3 letters are being in selection. All right. What if we are having 5 objects? Okay, we have 5 objects, and in this time around, we want to arrange it, but we are not going to arrange all of them. We want to arrange only 3 of them. So 5 different objects, and selecting 3 at a time. Selecting 3 at a time. So 5 different objects, 3 selection. What will be the total possible ways by which this could be selected? Are we together? We want to see how many is going to be. What are we looking for? We are looking for first number, second number, and third number, right? We want to arrange them only 3 by 3, 3, 3, 3, right? In how many possible ways can I select these 5 objects, 3 at a time? Remember, if I pick the first point, the first position, there are 5 ways by which I can select them because there are 5 objects. So 5 ways. So that means 5 ways independent for the first position. So I've taken the first one. So it means that I'll be left with 4 objects to be selected. So in the second position, there are 4 possible selections that can happen. So because I'm left with 4, so that becomes 4. Then in the case of I have selected the first, second, the third position, how many ways can that be selected? Out of 5, 1, 2 is gone. So 3. So that means I have 3. So I can make it 5 times 4 times what? 3. So this is the possible ways by which we can select that. 5 objects selecting 3 at a time. Do we get it? So if this is the case, we can rewrite this in terms of factorial. Right? We can write this 5 times 4 times 3 should be equals to 5 times 4 times 3 times 2 times 1. Have I introduced a foreign material? Yes. 2 times 1 is introduced. So let me take it away. 2 times what? 1. If I divide this by 2 times 1, this very point here is the same as what I'm having here. 5 times 4 times 3. Simple as that. I guess that is okay. Then what will be next? I can see that the numerator here is just defining 5 factorial. Because from 5 to 1, multiply all together. 5 factorial. Divided by from 2 to the next number. So 2 what? Factorial. So this is also being indicated. But I have not been given 2 factorial. But I can see that if I look at the 2 factorial, it is actually 5 items taken 3 at a time. So this will give me 5 factorial, 5 minus 3 factorial. 5 minus 3 give me 2. So this 2 is the same as 5 minus 3. So by general selection, if we are dealing with permutation, we are narrowing down to get a generalized way by which permutation can be performed, so that we will not be going through all these arrangements step by step. We go through direct formula. All right. Now, if we are taking the 5 selection to be n different objects to be selected, right? Then the 3 numbers I'm looking for is the R ways by which that could be selected. We can easily generate a formula. Let's see how that will look like. So we are picking n different objects, right? Which is 5. So n different objects. Then R selection, which permutation is P. So we use P and R equals to the n, which is the 5. So n factorial divided by n minus r factorial. So this is what we are having in this case. So it means that when I have n different objects to be selected, and I'm selecting only 3 at a time, that means that n permutation what? R. N permutation R equals to n factorial divided by n minus r or factorial. Don't forget that factorial affects the subtraction. Just like in this case, 5 minus 3 is 2. Then the factorial affects it. So this is the clear procedure to follow if you are dealing with permutation. In the next episode, we'll pick a lot of instances, as in examples, that will clearly depict the formula that we have. Then subsequently talk about the combination and combine the two together. Don't miss the next episode. Share this with somebody who you know might benefit from this. Let them subscribe to the channel. Keep following so that we learn together. Like, subscribe, share, and comment.